Hi, my name is John.
And my name is Alice, and you're watching Math Videos for Parents. We help you so you can help your kids with math. So today we're talking about the commutative property of addition. So, John, I'm just going to jump in on this one. So I know that when I went to elementary school and middle school, we covered this in middle school, but my understanding is now they're covering it younger. I believe they're starting in third grade, which is great because it's certainly something that a third grader can grasp. And really, all it's saying, the commutative property of addition, states that if you have a problem like 6 plus 12, then you can rewrite it as 12 plus 6. The order of the add-ins, which is the numbers that you're adding, don't matter. And I admit, when I learned this, it almost seems so obvious that it's kind of hard to grasp. It's like, well, of course, 6 plus 12 is going to be the same as 12 plus 6. So I thought of a few examples in life that are not commutative. For example, when you put socks and shoes on, you definitely do that in a certain order, right? Or you're going to have trouble going out the door. Another example of something that is not commutative, where order does matter, is if you're like me and you like your pie a la mode, you definitely want to put the pie on the plate and then the ice cream on the pie. You don't want to put the ice cream on first and then the pie on top. It's just not
It's
done.
going to be a mess.
You'd make a mess, yeah. So basically, John, what's your favorite number?
8.
8. Oh, good choice. So if you have something like 8 plus 10, because addition is commutative, you can rewrite it in any order you want, 10 plus 8. And these problems have two add-ins, but of course you could go to a much longer problem, and we'll do some sample problems next.
And I think that one of the reasons why this is introduced so early on is that, students are very familiar with base 10 blocks. They understand the 1 squares, the 10 rectangles, and the 100, big square. So for a problem like 8 plus 10, it might be easier for them to visualize starting with 10. If they start with one strip of 10, they know they have that, and then they're adding on 8 little squares to make 18. They might find that easier to think about than to start with 8 little squares and then add a stick or a 10 onto it. Or even with skip counting, a different might make it a little bit easier for quick mental math for students.
And there's a freedom in knowing that you can take advantage of that, that is an option for you.
Exactly. All right, I'm excited
Great.
to do some practice problems. Okay, so for our next problem, we are going to rewrite the equation 9 plus 10 equals blank. And just to remind everybody, an equation is a statement of equality. It's saying that the amount that's on the left is the same as the amount that's on the right. So you can think of it as a balance scale. Whatever I weigh on the left has to be identical to what I weigh on the right. So adding a 9 and a 10 together based on the commutative property would be the same thing as adding a 10 and a 9 together. I'm able to rewrite the problem in either order because they're both positive numbers, and addition is commutative, meaning the order does not matter. If I want to, I could also say something like 19 equals 10 plus 9. That is certainly true. If I wanted to add on the right side but not the left, I can also say something like 9 plus 10 equals 19. When it comes to equations, I think we're accustomed to thinking that the answer, if you will, has to be on the right-hand side, but it's best to not think of it that way. It's best to think of it as both sides have the same amount, regardless of how we write it. So whether we write 9 plus 10 or 19, what's on the left matches what's on the right. They both have the exact same quantity. And that just goes to, expand upon the Common Core standard of multiple representations. We can write 19 in a bunch of ways. We can write it as 9 plus 10, 10 plus 9, 19 itself, and we can certainly break it down many, many more ways. But for now, we'll stick to this. Alice, I'm curious to learn about your find the missing number problem.
Yeah, so this is another example where the right-hand side of the equation doesn't just have to have the answer in its final form. So if we look at our find the missing number problem, you can see we have some information here on the left, 8 plus blank plus 1. So we have an unknown addend. We don't know what's there yet. Then on the right-hand side, we have some information. We have 2 plus 1 plus 8. So there's a few ways you could approach it. Again, because addition is commutative, the order does not matter. So you can almost think of one side as like your shopping list and the other side is your grocery cart, right? So I have an 8 on this side and I have an 8 on that side. So we're good there. I have a 1 on this side. I have a 1 on this side. So we're good there. And now I have, an unknown on the left side and I'm left with a 2. So that means the 2 is what we need over here. So we can say, okay, 8 plus 2 plus 1 equals 2 plus 1 plus 8. The other way we could have approached it, though, is let me just rewrite the problem here, is to really focus on the fact that addition is commutative. The order does not matter. It's not like putting on shoes and socks where the order matters very much. So I can say, okay, well, if the order doesn't matter, then on the right-hand side, I can move things around. I can say I'm going to put my 8 over here. And that way it's going to kind of recreate the pattern that I'm seeing on the left-hand side. And then it becomes really clear of what the unknown is, which is a 2. And so that's just another way you can approach the problem. And then I always like to also put what the answer is. So 8 plus 2 plus 1 is going to give us 11. No matter what order we write the 3 addends of 8 and 2 and 1, it's going to give you 11 as the answer.
That's awesome. And like you said, commutative property is introduced at a very young age. And I think it's important because students will use this in middle school. They'll use it in high school once they start working with geometric proofs and with algebra. And they'll even see it in college if they go that far. When students take abstract algebra, they study groups and fields and more advanced concepts like that. And the concept of commutativity comes into play there as well. Even with matrices in linear algebra, multiplying matrices generally is not a commutative property. So it's a very, very, very important concept. Even though it might seem very easy in this video, it has very widespread application through the mathematics sequence. And you bring up a good point, John, that not everything in life is commutative and not everything in math is commutative. Addition is, so that's important to know, but it's also going to be important to realize we can't always assume that for a mathematical operation. So we'll do some more videos on the commutative property in the future. Sounds great. Thank you all for joining, and we look forward to hearing from you soon. Please subscribe to our YouTube channel, like our Facebook page, and send us a line if you have any problem requests or would like to see anything illustrated. We'd be happy to make a video on it. Thanks for watching. Thank you.